Hello and welcome at our special episode. I will show you some good examples of the couplings and boogie settings. So let's go on. I've built this small basic railway. It's a little bit different style because this uses only one gate and everything is built with the armor blocks. Yeah, these lines are only for moving with the train. So here is some kind of train. I can call it like tram. It doesn't matter. It's a simple train. It has several thrusters. It's powered by the cruise control programmer block or the script, and it works quite well. I made two versions of this one. The red one has dynamic bogies, which are on the rotors, and the blue one has no bogies. And the difference between them is really big. They are similarly fast, but the red one is still my favorite because it's much more better. You can see it's traveling, it's working really well. I made lots of updates on that railway. I spent like 2 or 3 hours building it and preparing it. These simple railway switches, they allow me to rotate the train. Now I turn it off, then I can easily turn it around. Now all the wheels have zero friction, which is quite important. That will be one point in this proving video. You now saw how it works. So what does it will do if I add some friction? For example, something above 30% for both of the types of the wheels, so the middle wheels or the side wheels and the main wheels. I can little bit decrease the strength so all the wheels will touch the ground. And I can feel that it's quite slower. And no, I can't move. Why these wheels don't rotate? That's a question for me now, because they should rotate. But they don't want to. I can check these blocks in the middle, because sometimes it's possible to place these blocks, but it will not work. Still enough power. Move it a little bit up. And no difference. I can try to turn off everything and still don't work. Okay. Okay, now it's working. The main problem can be the middle wheels. They are blocking me a little bit, so I can decrease their friction and okay, there will be friction and the side wheels will have no friction, so it should be a little bit better. And we can see that there's very strong force on the side wheels, and I can't move because the friction of the wheels on the bogies is so strong that it does not allow me to move anymore. I will make some more space for the wheels. And still not enough. I can check the rotors. Yeah, of course. Okay. So I must a little bit increase the threshold. But still it don't work so well. And that's everything. Yeah, I can't move now at all. So I can try to increase or decrease the strength. And still don't work. Okay, so you can see the friction isn't our friend, because sometimes it don't work with the friction. Okay, that's what I wanted, because now the bogies are correctly positioned. So now you can see the speed is not decreasing. Then I will set some friction and the speed is now decreasing because of the friction of the wheels. And now turns. While turning, the bogies allow me to move a little bit better, because they help to transfer the forces and they allow better steering. Oh, it's working. It's not the best solution, but it's working. So it should be possible to move with the train only with the wheels and don't use any thrusters like me now. So that's a first test. The second one, okay, I will stop this train and place it anywhere else. I will use the new one with 0 frictions, and I will use 2 of them. Yeah, so you will see how does this work. I will just keep the dampeners offline in this one. Here they can be offline. So now each cars are connected with the connectors. There is no information or power transfer. It allows me rotations, and there are no hinges with the horizontal axis, because there are no ups and downs. We are going only left and right, but it's perfect example to show how the coupling can work. Yeah. So now we have this easy coupling. There are 4 blocks between these 2 hinges, and we can see that this distance is crucial. Okay, I will try to catch. And you can see the movement. Now that was very critical place, because if we are going like left and then right, then your rear part and front part will go in the different directions, and that can be a problem if you choose very short coupling. I will reach the straight line, stop the train, Okay, I will take the engineer, and now I will place there only the connector. Or maybe I can use, for example, this rotor, so it will transfer power, but that's not a need. Okay, which one? This will be this one. So attach the rotor, and of course I should turn it off. And now again similar functionality, but the coupling is now very short. Instead of 4 blocks, it has only 1 block. In these lines, it's still okay, because it's a little bit simple. But it's on the limits, and now it will have a little bit problem. You could see the tilting of the train because there was some force on it, which is not correct. And now it seems it's a little bit broken because the second car wasn't so straightly, and that's all, because there are forces we don't want, and that can be a problem. Sometimes, of course. You are maybe thinking why there are these armor plates. They help the train to find the correct way. So it little bit helps, but sometimes it can just the train will hit it and stop it. So that's why you should use enough long the couplings. Now back to the our train. Now the bogies. I said, or I showed anything I wanted to show around the couplings, because this was only their length. Functionality at all, everything said in the last video. Now the bogies. The bogies are the main reason on this red train. It's working quite well. If I stop it, we can check these rotors. They have limits, because if I place the train somewhere, so the bogies will not rotate around. So they have their limits. And of course they are turned off with the little bit braking torque. It prevents very bad behavior. For example, I can turn it on now, and now we have active like 400, almost 50 kilonewton meters, and we can see the bogies are not rotating, because that strength is too much big. So I will turn it off, and now it's at the 0, so there is no force which will be, how to say, block it a little bit. So it's working quite well, but sometimes in higher speed these very free bogies can have a small problems. Like now, that bogie went like too far to the right and it needed go to the left. So that's why I use a little bit of force. That force depends on the mass of your train and speeds, so you need to test it. But I can recommend something like 20, only 20 kilonewton meters, because that works quite well. I can set the 10 meters per second now, and we can see it's a little bit it's a little bit better. It's not so free, but still it has a little bit behavior. Okay, not at all, but usually it should be. It should be. I don't know if it is a good example, this train. So that's the first topic to the bogies. I can show the version without them. So this version has the wheels on the side. Yeah, it's on the front and rear side. At the edge of the train. So if I now enter down some speed, we will see the behavior is different. The wheels settings are the same. I can't use more wheels because there should be some kind of collision. You can see it's working, but it's not the best one. So that's why I want to show a little bit of difference. I will just check the setting, the side wheels. Friction, okay, that's okay. The height offset is crucial for me, and strength, yeah, it's minus 27. So now I can easily remove these wheels. And I will place them, instead of there, somewhere here or here, yeah, more to the middle, but not too much, not too much. So now I need to apply the setting. I can turn everything off. Minus 27, strength, okay, that's everything. Yeah, maybe you are also asking why I use only 2x2 wheels and not 3x3. It's because that hole for the one block has 5 small block wideness, and if you use 3x3 wheels, then you have 6 blocks, so there is collision between the wheels in the basic block, and you must count with that this hole is smaller than this one because of that angle, yeah. So that's why you need to use 2x2 wheels, so there is some kind of area where you can easily move. So now same train but different position of the wheels and without any bogies. I can check the wheels, zero friction. The reaction is now different. You can see it's like jumping and so on, because we are quite fast. But in this case it's a little bit better, yeah? But still the result is simple. Bogies are better. Bogies are better, yeah? So that's for the bogies. Now how to attach them, or how to create them, or how to place them. The first is length. The length should be something proportional to the train. I can say the maximal length of the bogie should be 30% of the length of the car. Yeah, so it's like 30%, 30% in the middle, and 30% on the second side. Yeah. Their parameters like diameter, it depends on you. I used 2x2 because they are the smallest one possible to use in this case. Yeah, for this kind of the railway, I should use bigger bogies, because now we can see my front bogie has its own left side in the air. But still, If you have some smaller hole, like somewhere in the middle, I can move there. The bogies there work quite well because there is very yeah, the boogie should be a little bit bigger, but it still works if you move at least several meters per second, and if you move faster then it's smooth without any problems. Yeah, but yes, of course the boogies should be a little bit longer, but I wanted to make it as small as possible in this way, so train works quite well. So now, how to attach them? The possible solution how to attach the boogies. I will pick this one camera, so we will see below the train. There is very small rotor. The rotor is in the middle of the boogie. That's, for me, I can say that's the best place for the boogies, for the rotors. I'm sorry, for the rotors. I can propose you to use usually 3x3 rotors because they are a little bit more stable than these ones, because these ones are not so stable. So I think that's all. The wideness, the length, everything is on you. Yeah, usually I propose to place these inner wheels, the side wheels, more to the side of the, not the side, but to the front or rear end of the boogie, more than the main wheels. Yeah, because they will then react to the change of the direction faster. Yeah, because in the direction the first one hit this wheel and then this wheel, so it's a little bit better. Of course you need enough space for turning the boogies, that's why there are lots of space below that, and that's why I used there only these panels, so it allows free rotation. Next I can maybe show you, you already saw how they work. Now I can try show something a little bit different. If I put their rotor somewhere here, and here, then I will remove the head. Oh. And place the head on the boogie. So now I will pick the engineer and I can easily attach these rotors. And I can now detach the previous rotors. I will just turn them off, some braking torque, and we will see how they behave. Yeah, maybe some tip and trick. If you use your f8 camera for building or following the train, and if you want to follow something, some grid, you just aim at that grid and click your start button. It will start or stop following that grid. You can follow anything you want, and if you use the button on the left from the star, it's the kind of slash, that you can little bit change the camera behavior. There is like orbit mode, which allows you to rotating around the grid. Known mode, free mode, follow mode. So now we can see how these bogies will behave. I think there is some kind of... Okay, no, there is no... So it's working okay. It's okay, it's nice. Now it had several problems with it. The main problem, you can maybe see it, is that there is no distance. There is no distance between the front and rear wheels and the rotor. So it can't follow anything. And that's the main problem. Yeah, it can't follow anything, so the traceability is not okay. So that's why you shouldn't use these kind of positions, but they have some advantage. Yeah, I can see the limit now. There is a collision, so now that's the problem I had. Okay, so now it should be a little bit better. But it's perfect example to show something good at it. The traceability still don't work, but I can show something. If some kind of train will be moving very fast in the turn, they are under the centrifugal force which push them in this way. In this turn, it will be pushed this way, and it can derail. But if the bogies are like this, they increase the distance from the middle to the side, and it will increase the... I don't know how to describe it. It's some kind of lever. Maybe, yeah, it can be described with the torque. There, to measure the torque, you need to know the force applied and the distance from the middle of the rotation. And if we move the bogies like this, we increase the distance, so the torque needed to derail the train must be a little bit bigger. It's not much, it isn't so much, but still it can help you to not derail train if you don't want to use any supporting wheels. So that's the main reason to place rotors anywhere else. But I can say this rule is applicable only if your bogies are really long. I mean really long. Much more longer than these ones, and if they use more wheels, for example, they will be more stable and better. So for this easy topic, I think that's all. I can let the train travel, place them there, the second one, and that's all. It's easy tram, just hop on and you are moving. It's like a playground. You can sit there and watch it. Of course, it's slow. For this example, it can be faster, yeah. But at least it's working. And I think it can be really easily automated. So have a nice day and goodbye.